Hey guys, so this would be exercise 12.1. I'm going to go through all the problems in your book that pertain to this lesson, and then on the following video I'll do 12.2 as well. And again, this is for your benefit, for you to kind of, if you miss something, if you didn't understand something, whatever it may be, if you're absent, you can kind of slow down or even fast forward through some of these parts which you feel pretty confident in. Nonetheless, again, this is just for the benefit of you in preparation for the quarter exam on May 27th. All right, so let's go ahead and do the first problem in 12.1. I'm just going to do A and B for this problem. To convert angles to degrees, all we're going to do is multiply by 180 over pi. Okay, so at this point, pi's will cancel out. We have 180 over 8. That will end up simplifying as 22.5 degrees. Okay, so again, pi over 8 is equivalent to 22.5 degrees. This is in radians, this is in degrees. Let's do the same thing here. Multiply by 180 over pi. Pi's will end up canceling out. 2 times 180 is 360. 360 divided by 3 will end up being 120 degrees. And again, these are equivalent to each other. We've just transformed just from radians to degrees, but they mean the same thing. They're just different ways of measuring it. All right, so now we have problem number 2 out of 12.1, converting angles to radians. Again, these are both in degrees. To go from degrees to radians, we are going to multiply by pi over 180. Okay, so at this point we have 210 pi over 180. This would be equivalent to 7 pi over 6. Okay, again, degrees to radians, we're going to multiply by pi over 180. 240 pi over 180 is equivalent to 4 pi over 3. All right, number 3, we're going to start graphing. So the good part about this is you've done this before. The only difference is now we're going in radians. Okay, this is the only single difference between the last chapter and this chapter. Well, I mean, as far as this this lesson goes. Okay, so we're going in radians. You do the exact same thing. Okay, so don't get confused. We still have to figure out max, min, and axis just to know what those values are. Okay, so max again, b plus a, -1 plus 2 is a +1. Min, -1 minus 2 is a -3. Axis would be -1. Okay, let's go ahead and label those points. So our max is 1, our axis is -1, and our minimum is -3. Okay, so again, we have to put this in radians. So instead of going from 0 to 90 to 180 to 70, 360, we are going in radians now. So that was going to look like 0. Okay, 90 is pi over 2. 180 is pi. 270 is 3 pi over 2. And 360 is equivalent to 2 pi. Okay, and again, this looks like that. You're going to do this the same way. Again, only difference is radians. So for cosine, again, I'm going to start off, whenever I start off at 0, I'm going to start at my max, back to axis, min, axis, and max. So this is how your graph should look like. All right, 3b. 3b, we have an absolute value within our graph. So again, do this as if the absolute value was in there. So again, I'm gonna graph this using my max, min, and axis, and I'm going to pretend as if the absolute value wasn't there. Okay, so again, pretending if these two brackets were not there, 1 plus 1, that would be 2. Minimum 1 minus 1 would be 0. And then axis would just be 1. Okay, so let's go ahead and put our values. Okay, again, we're going in radians, so that would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so we're all ready to go. We just have to graph this, again, as if the absolute value wasn't there. We'll apply the absolute value after. Sine, again, sine starts at axis. Okay, back to max, axis, back to minimum, and then to axis. Okay. Okay. So now, let's apply the absolute value now. Again, that plus 1 is on the outside, so we know that anything below 1 is going to go up. Okay, so this is going to reflect up above 1, so it's 1 unit down from 1. It's going to go up 1 unit. All right, that is the only thing below 1. So let's go ahead and erase this. This is not there anymore. So our graph should end up looking like that. All right, so 3C. 3C, again, we have absolute value. Pretend it's not there. So max, min, and then axis. Again, pretending not that the absolute value is not there. So max, -1 plus 2, that's +1. Minimum is -3. Axis is -1. Okay, so this is how those main points are going to look like. We're still going from 0 to 2 pi.
Okay, now let's go ahead and practice. Again, sine is going to start off at max. Hold on. What? Okay. 0, pi over 2, pi, 3 pi over 2, 2 pi.
So we are going to start at our axis, which is -1, then to max, then back to our axis, back to our minimum, which is -3, and then back to axis. All right, so then we have to decide, well, where is our reflection point? Everything is within absolute value, so our reflection point would be at 0. Okay, so anything below 0 is gonna go is gonna reflect up. Okay, so actually this is the only thing we are keeping. Okay, so that's the only thing above 0. -1 turns into a +1. -1 again turns into a +1. This -3 turns into a +3, and then this -1 turns into a +1. Again, reflecting everything above 0. So all of this is going to go away. And what we have here is our new graph, which ends up looking like that. All right, what we have for 3D is really the only change is, again, I don't want you to get confused. This is 2x, so our interval is going to change. So you still do the same thing. Again, you've done this before, except now it's in radians. So this is really nothing new. Max is 4. Min is 2. Axis would end up being 3. Again, that 2x means we divide everything by 2. So instead of going 0, 90, 180, 270, 360, we go by 0, 45, 90, 135. Okay, we just have to know how these look like in radian mode, or radian form. So again, we're still going to start off at 0. Instead of going pi over 2, which is 90, we're going to go pi over 4, which is 45. Okay, and then to 90. Okay, 135 is 3 pi over 2. Again, if you're confused, just add 90, just add 45, so you can add pi over 4 to pi over 2. You end up getting 3 pi over 2. Okay, again, you can use this to your advantage because this is equivalent to 45 and you're going up by 45. So if you're ever wondering what rating do I use, you just add pi over 4 to whatever your last step was. Okay, pi over 4 plus 3 pi over, sorry, this is actually 3 pi over 4. Pi over 4 plus 3 pi over 4 is, of course, pi, 180. Then comes 5 pi over 4, 3 pi over 2, 7 pi over 4, and then finally 2 pi. All right. Let's make our y-axis. All right. Now let's get started to graph this. So sine, again, sine starts off at your axis, which is 3, and then back to max, back to axis. Your minimum is at 2. Okay, again, you're gonna follow how a sine graph looks like. Okay, so this is exactly what you should have for sine 2x plus 3. All right, we've got 5 cosine 2x between radians 0 and 2 pi. All right, we gotta start figuring out. Again, just be careful of that. That means divide everything by 2. So we're gonna go by steps of 45. Max, min, and then axis. Max is going to be 5. Again, there's nothing here. 0 plus 5 is 5. Minimum is going to be -5, and axis is going to be 0. All right? So 5, 0, -5. Let's make our radians, our x-axis. That will end up being 0, pi over 4, pi over 2. Again, we're going by 45s. 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and then 2 pi. All right, so now we can go ahead and graph this. Cosine, again, cosine starts at the top of the hill. Work our way down, work our way up. All right, so what we have here is 5 cosine 2x. All right, 10x plus 1 between 0 and 2 pi. We haven't done a tan problem yet, so this is a good problem to do to refresh your memory. Max, 1 plus 1 is 2. 1 minus 1 is 0. Axis is, of course, 1. Okay, so we have 0, 2, sorry, it should be 1, and that's 0. All right. Again, tan naturally goes through steps of 45. So we're going to have 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Okay? All right. Before you actually do that, note down your asymptotes. Okay? Your asymptotes are, of course, just naturally are 90 and 270. Okay? So 90 would end up being right here. So there is an asymptote. 270 would end up being right here. at 3 pi over 2. Okay, so all ready to go. Okay, so again, we have 3 sections. Let's work on this first section first. All right, tan, we'll start off at our axis and then work our way up. So this is how the first one looks like. Then we go from min, axis to max. Okay, and then min, and then axis. Okay, so that's how your tan x plus 1 should look like. Let's do 4. We're graphing 3 cosine 2x minus 1, except now we're doing 0 to pi, which is 0 to 180. And again, we're going to go through the same exact steps. Okay, actually you guys are pretty good at graphing. For a max, again, -1 plus 3 is a positive 2. Our minimum is -4. Axis would end up being a -1. Okay, so we have everything we need. Max is 2. Axis is -4. And minimum is -4. Axis is -1. Minimum is -4. Again, this is 0 to pi. Of course, we have to note down where our interval is changing. Okay, it's going to be a much smaller graph because of this, or a scrunched up graph. So I'm not exactly sure how many we need, but okay. So cosine, we're gonna go 90 divided by 2, so everything is gonna be in steps of pi over 4. So pi over 4, we got pi over 2, which is 90. 3 pi over 4, 135, and then of course just pi. All right, so we can go ahead and graph this. For cosine, again, we start off at max, axis, back to axis, and then max. All right, so this is how your 3 cosine 2x minus 1 looks like. B. 4b. This would be 4b. All right. So don't get confused by this. This is just putting it in reverse. Okay, so you can read this as, how about we change this to sine 2x plus 1, just so you don't get confused. Max, min, axis. Max would end up being 2 here. Min is 0. Axis is 1. Okay. So max is 2. Min is 0. Axis is 1. We're going from 0 to pi, except now, again, we have to note down our interval is changing, or our period is changing. So we go from 0 to 45 to 90 to 135, and then back to pi, 180. Okay, sine, of course, starts at axis. Max, axis, min, axis. All right? All right. We have y is equal to absolute value of tan 2x, and then plus 1 on the outside. Again, pretend as if the absolute value wasn't there, and then apply it after. So let's go ahead and do that. Max, min, axis. Again, we're pretending the absolute value is not even there. Okay, so just imagine it's not there. 1 plus 1, max is 2. 1 minus 1, min is 0. And then axis is 1. Okay. Let's go ahead and put that down. Again, let's make our y-axis. Again, we're going to eventually reflect things up, so we just kind of have to make sure our graph is helpful towards that. Okay, so again, this is a 2x. So instead of naturally going by 45 steps, we're going to go 22.5, okay? So if you're confused by that, again, if you know pi over 4 is equal to 45, well, what would end up 22.5 being? You can just divide this by 2. Okay, so if you divide this by 2, you would end up getting pi over 8, which is equivalent to 22.5. Okay, so you can use this to your advantage, adding pi over 8 to each step, just so you make sure you're going by 22.5 instead of 45. Okay, so pi over 8. Again, I'm adding, well, this is naturally 45. You should know that already. Pi over 8 plus pi over 4 would end up being 3 pi over 8. Okay, that's so our next step would be, of course, we get 90, which is pi over 2. We get 5 pi over 8. Next, 3 pi over 4, 7 pi over 8, and then pi ending at 180. And now we are ready to go to graph. Before I do that, we have to start thinking about asymptotes. So again, we have asymptotes usually at 90 and 270. But again, we've divided this by 2, so we have to divide these by 2 as well. So instead of 90, our asymptotes will be at 45 and at 135. Okay, so where are our asymptotes? Again, 45 pi over 4, and then 135, which is at 3 pi over 4. All right, now we are ready to graph. So again, 10, once it starts at 0, it starts at its axis, which is at 1. Okay, goes to max 2. Okay, so this is how first section is looking like. Min, axis, and max. Okay, min is 0, axis, max. Okay, and then again, min, and then axis. Okay, again, we're not done because we have absolute value of tan 2x plus 1. So plus 1 is our reflection point. Anything below 1 is going to reflect up. So what's going to reflect up? Well, this is going to reflect up. It's below 1. So instead of 0, again, how many points is this away from 1? It's 1 point away from 1. So it's going to go above 1. Okay, so we can get rid of this. This is below 0. Again, how many points away is 0 from 1? That's 1 point away. So it's going to go 1 point up. Okay, so this, again, now you can adjust your graph. Everything is above 1, looks good. So this is how tan 2x within absolute value plus 1 should look like. 4D. 4D, again, our period is going to change. It's going to be much in smaller intervals. This time we have 3x, so we're dividing everything by 3. So we're going to go from 30, 60, 90, and so on and so forth. Okay, so max, min, and axis for this negative 2 plus 4 is 2, negative 6, and axis would end up being negative 2. So axis is at negative 2, max is at 2, at negative 6. We're going to go from 0, again, we're going to go by 30s. 30, you should know that would be pi over 6. We're going to add pi over 6 to each additional step. Okay? So pi over 6 plus pi over 6, pi over 3. We got pi over 2, 2 pi over 3, 5 pi over 6, and then pi. Okay, we actually don't need this at all. Alright, so let's go ahead and do this. We are going to, again, cosine starts at, in the middle at axis when it starts at 0. We're going to go top, back to axis, minimum, axis, top, back to axis. Okay. Alright, 5, considering basic angles, evaluate the following. Now, naturally all these follow your unit circle, which you should know. Again, you know it in degrees, you should also know it in radians, which is a test. Okay, so again, just follow, your unit circle is always going to be cosine sine. Okay, so if you know that, naturally you know all these values. So this would end up being 1, square root of 2. B is square root of 3 over 2. Tan, again, tan's not on your unit circle, but you can still figure out, well, you know that tan is also sine over cosine. So by knowing that, once you go to 7 pi over 4, naturally you're going to go to those values, sine, and then put that over cosine, and you should end up getting -1. And then finally, sine 7 pi over 6 on your unit circle is -1 over 2. Okay, so these are all your values. Again, you should know your unit circle. Be very familiar with that. All right, for 6A, 6B, and C, I mean, there's not much to say about this. You just have to know how to use your calculator. Okay, again, like for 6A, all this is in radians, and how I know that is because there's no degree mark. Okay, like for example, if we compare that to B, B has tan 1.2, which is in radians, but minus sine 40 degrees. So this is in radians, but this is in degrees. So you'll have to do them separately within your calculator. Okay, so you have to go to shift mode, go to the correct measurement. Again, this would be in radians, so you get that in radians separately from when you get sine 40 in degrees. And then you would end up subtracting them together. But again, there's not much to this, so I won't really go over it. You just have to know how to use your calculator. All right, for 7, so find the values of x where 0 is between, or x is between 0 and 2 pi, which satisfy each of the following equations. For number 1, cosine is x is equal to square root 3 over 2. B is tan x is equal to 1, and C is sine x is equal to -0.5. A and C you can naturally get through your unit circle. You can also draw them out if you so please. B is something you can't get within your unit circle, but naturally you can still draw a diagram out. So let me just do B, just for the sake of doing at least one of these. Again, this was actually one of your practice problems in your video. So we have done this in class, but let's try this out one more time. Okay, so tan x is equal to 1. Again, you've done these problems before, just the only difference is that this is in radians now, just like all of these problems really. So tan x is equal to 1, well, it's positive. Tan is positive. Well, where is tan positive? Well, tan is positive in Q1, okay? And tan is positive in Q3. Okay, so what we're trying to find out is this angle and this angle. So when it comes to this angle, we have opposite. Again, let's change this to 1 over 1. So this would be opposite over adjacent. 1, and this would be square root of 2 because, well, naturally this looks like a special right triangle, 45, 45, 90. Again, this would be 1, 1, square root of 2. So we can say that this is 45. We have base angles of 45, or alpha of 45. Okay, well this would end up being pi over 4. Okay, and this would end up being, well, again, if this is pi plus pi over 4 would end up being 5 pi over 4. Okay, so those are our two values for tan x is equal to 1. Alright, so 7D we have 6 sine squared x minus 1 is equal to 0. Again, we're trying to find all the values between 0 and 2 pi in radians. So these are equations. Naturally, you could use identities in any of these problems. I don't think we'll happen to use them in this scenario. We might, but let's try to find what ends up being equivalent to sine x. So plus 1 divided by 6, we have sine squared x is equal to 1 over 6. Let's get rid of that square. Okay, so sine x is equal to a positive or negative square root of 1 over 6. Okay, now here, you're going to have to use your calculator. Okay, so this is your ratio of sine, okay, of the sides according to sine. You'll have to find out what the angle is, or the base angle, according to this ratio of sides. Okay, so now how you do that is you go in your calculator and you say, well, what is sine? So you go to shift sine. This will pop up in your calculator, okay? And you'll have to put square root of 1 over 6. You'll also have to do that one more time because this is positive and negative. You'll also have to do that for a negative square root of 1 over 6. Okay? Now, I've done these already, so when I put this in my calculator and I say sine negative 1 square root of 1 over 6, I get a base angle of 0.4205. And of course, this would be negative 4205. Okay? Now these represent my alpha, or my base angles. So what I mean by that is if we draw a diagram here, we have 0.4205. Now tell yourself, well, where is sine positive? Sine is positive here in Q1. Okay, add sugar, well, here as well. And we know it has a radian degrees of 0.4205 and also 0.4205. Okay? We just have to know, okay, what these exact values are according to our theta. Okay? So, we're going to end up having two angles, at least for this first part. Theta would end up being, well, this one's pretty easy. Again, 0 plus 4.0205. That's one of our answers. Well, how do we end up getting this theta? Again, we're going from here to here. Well, what is that theta? Well, that would end up being, remember, if this is pi, just do pi minus 0.4205 to find out what this angle is. So pi minus 0.4205 would end up being 2.72. Okay, so those are our angles according to this scenario. Let's find out our angles according to this scenario. Okay, well, again, where is sine negative? Sine is negative here and here. And of course, we have the base angle of 0.4205. Remember, even though this is negative, this is a base angle, which are always positive. So 4205 and 0.4205. Okay? So again, tell yourself, you have pi on this side, 180, all the way on this side is 360. Remember, we go from 0 to 360. So, what's pi plus, we're trying to find this angle, what's pi plus 0.4205? Okay? that would end up being 3.56. And to find this, well, how about we just kind of work backwards? We can say 2 pi minus 0.4205 to find out what this angle is from here to here. That would end up being 5.86. Okay, so again, we found all our angles according to our base angles, which is 0.4205 and negative 0.4205. Okay, we just kind of have to work around our unit circle. All right, 7e. 7e says 2 sine x minus cosine x. Again, whenever you're in this situation, try to move something to the other side. Okay, so let's move over cosine x plus cosine x. 2 sine x is equal to cosine x. And look, I mean, what can we end up doing here? This is where your identities end up helping you out. Because ultimately, you want to use, one trig function. So what ends up happening here, well, this cosine x divided by cosine x is 1. Sine over cosine x is just tan. And we have 2 tan x is equal to 1. Okay, so you kind of know where I'm going here. So tan x is equal to 1 over 2. Okay, so we have the function of tan equal to the sides of 1 over 2. Now, naturally, again, we're trying to find the base angle of this. So let's go ahead and do arctan of 1 over 2. Okay, and we should end up with a base angle, which is in here and here. Okay, we just have to figure out what these base angles are. Okay, so I figured out the arctan of 1 over 2 has the base angle of 0.463. Okay, so that means, again, base angle here is 0.463. And the base angle here is 0.463. Okay, we just have to figure out what these exact angles are. Okay, well, this one's pretty easy. Okay, that would just end up being 0.463 because, well, 0 plus 0.463, this angle is just 0.463. Okay, well, if we're going all the way around to this angle, well, how big is this angle? Okay, again, use the values you know already. This I know is pi. Well, what's pi in addition to 0.463? Okay, that would end up being 3.604. So again, we just found our two values according to this function, or two angles according to this base angle of 0.463, which is 0.463 and 3.604. All right, let's try 7F. Again, the best thing to do is put one of these on the other side. It doesn't really matter which one. Okay, we end up having 3 sine x is equal to negative 2 cosine x. Again, naturally, we should probably use divide by cosine x, divide by cosine x. That way we have tan here. So 3 tan x is equal to, this cancels out, negative 2, divide by 3, divide by 3. Tan x is equal to negative 2 over 3. Okay? Now, we know tan x is equal to negative 2 over 3. Let's find the base angle of tan x equal to negative 2/3. And how do we do that? Well, we go to our handy dandy calculator. So these are the sides. What is the angle according to these sides? We can figure that out by doing shift tan in our calculator. We have negative 2/3 that we're evaluating. The base angle according to this is negative 0.588. Okay, now these are base angles. What it just got for you is a base angle, so we don't really need this negative. Okay, so this is what we're evaluating, negative 0.588. Okay, so ask yourself, well, where is tan negative? Okay, again, add sugar to coffee. Everything is positive here. Sine is the only thing that is positive here, so tan would be negative here. Tan is positive here, but tan is negative there. Okay, so again, base angle is 0.588, 0.588, right? And then we can start using some of our, boundaries to kind of work off of this. Because we know this is pi, this is 2 pi, 360. So let's work backwards, okay? If we have pi here, if we work backwards, again, we're trying to find this angle, this angle up to here. Well, how do we end up doing that? Okay, pi minus 0.588. Okay, that would be one value. And if we're trying to find this angle, okay, how can we find that? We can find that by doing 2 pi minus 0.588. Okay, so your answers are so my pi minus 0.588 is 2.55, and 2 pi is approximately 5.70 radians. Okay, so here are your two answers for this one. Again, those represent those two angles. 7G has, it looks a bit different since we have cosine 40 degrees. You do want to evaluate that in degrees. This ends up being equivalent to 0.766. Okay, well, 0.766 times cosine x is just 0.766 cosine x, right? And of course, on the other side, we haven't changed anything. How about we divide by cosine x? Okay, this will end up canceling out. This will end up canceling out. So you have 2 sine x is equal to 0.766 divided by 2. And sine x is equal to, this would end up being 0.383. Okay, so again, to find the base angle according to this ratio, do arc sine, and arc sine of 0.383. Okay, then ask yourself, well, where is sine positive? Sine is positive here, and sine is positive here. Okay, we have base angles of 0.383, 0.383. Okay, so again, pi here, we're actually starting off at 0 here. 0 plus 0.383 is just, when I put this in my calculator, I actually end up getting 0.93. Okay, so again, I kind of skipped this step. But once you put this in your calculator, you get a base angle of 0.393, which is awfully close to 0.383, right? You end up getting, your two angles end up being, of course, 0 plus that is 0.393. And pi, again, I'm going backwards, so you're trying to figure out what this theta is, that would end up being 2.75. Okay, so those are your two angles for this scenario. All right, 7H. You guys kind of, there is actually a similar problem on the quiz that you guys sort of struggled on it. Let me kind of go through this step by step. So we're trying to figure out what cosine 2x is equivalent to. Notice 2x, okay? But that'll kind of come in, we'll talk about that a bit later. Cosine 2x is equal 7 over 10 is just 0.7, okay? So then you start thinking to yourself, again, there's nothing else you can do, but 2x means it goes around it twice. So you're actually going from 0 to 4 pi, okay, instead of 2 pi. And again, we'll kind of explain that through the graph. But when you do put this in your calculator, okay, so just find out what cosine -1 2x is equivalent to as far as its base angle. Its base angle ends up being 0.795. Okay, so now I know what its base angle is equivalent to. So let's go ahead and draw our graph. Add sugar to coffee, so we know it's positive here and positive here. So 0.795, 0.795, okay? So remember, 2x means it goes around the circle twice. So we just have to figure out what 2x is equivalent to, okay? Well, 2x is equivalent to, again, we're going from 0 to 0.795, so we can figure out this pretty easily. That's just equivalent to 0.795, okay? Let's keep going around the circle. Well, how do we find out that angle? How about we just use 2 pi to our advantage? 2 pi minus, okay, 0.795 is going to be equivalent to 5.488, okay? And look, guys, we're going to go around this twice. 2x means we're going to go around it twice, so let's keep going around, okay? I'm going to go hit this once more, okay? Well, 2 pi plus 0.795, again, 360 plus that radians is going to end up being, again, all I did was 2 pi plus 0.795. This is equivalent to 7.078. Okay, again, I'm going around this thing twice, so we're going to hit this once more. Okay, well, what is that angle? Again, the fact that we're going around this twice means this, instead of 360 or 2 pi, now this is 4 pi, 720. Okay, we'll just do 4 pi minus 0.795. We get 11.77. All right, so we have all our values equivalent to 2x. We have to divide each of them by 2. Okay, we end up getting x is equal to 0.398, 2.74, 3.54, and finally 5.89. Okay, so these are all our values for x. Okay, from 0 to 4 pi. All right, we have 7i. 7i tells us cosecant 2x minus 1.2 is equal to 1.2 radians. Okay, so remember what cosecant means. Cosecant means 1 over sine. Okay, if cosecant means 1 over sine, 1 over sine is equivalent to 1.2 radians. Now, we're going to change this up a bit since it's hard to kind of interpret this from here on out. How about we just do sine of 2x minus 1.2 and take the reciprocal of this, which is 1 over 1.2. Okay, again, this means the same thing. We have flipped this over instead of cosecant. Okay, so now we have, let's find out the angle or the base angle in reference to 1 over 1.2 radians. So we're going to go ahead and do sine or arc sine 1 over 1.2. Okay, that would be equivalent to 0.985. Okay, so this is our angle in reference to radians, our base angle or alpha in reference to radians. So what we have here is, again, where is sine positive? Okay, sine is positive here and sine is positive here. You have 0.985 and 0.985, right? So let's go ahead and try to figure out what this is in reference to our base angles. Okay, so again, look back on your on how this is interpreting the angle. This is going to go around it twice since it's 2x. Okay, so the first time I go around, well, that's 0.985. Okay, so one of your answers is 0.985. Just go ahead and put that here. Okay, if I keep going, this is my second angle. Okay, this angle, let's do pi. Again, this is pi. Pi minus 0.985 is equal to 2.156. All right, let's keep it moving. Again, I'm going to go around this twice since it's 2x. All right. Okay, so this is my new angle. Now I can say, well, what would 2 pi plus 0.985, that would end up being 7.268. Okay, let's keep it moving. All right, up to here. Now again, if this is 2 pi, this would end up being 3 pi now. Okay, so what's 3 pi minus 0.985? That would end up being 8.439. Okay, so again, what is this all equivalent to? This is all equivalent to 2x minus 1.2. You just have to solve for these individually now. Okay, so 2x minus 1.2 is equal to 0.985. Okay, you add 1.2, add 1.2, and then divide by 2x. You would end up getting 1.09. Do the same thing here, add 1.2 to this, divide by 2. You end up getting 1.678. Okay, and I'll just tell the answers for the rest, 4.234 and 4.819. Okay, so here are your values when it comes to 7i. All right, our final one, 7j. So 7j, you're actually going to use one of your identities. Again, it's in your best interest to have one to deal with your one trig function. So I do see an identity I can take advantage of here. Cosine squared x is equivalent to 1 minus sine squared x plus, and let's just write out the rest. Okay, that we can distribute here. 2 times 1 is 2. 2 times negative sine squared is 2 sine squared x. Let's write out the rest. All right. let's move everything to one side. Minus 1, minus 1. That turns out to be 1 minus 2 sine squared x plus sine x equal to 0. Let's clean this up a bit. So let's put the one with the highest degree first. Minus 2 sine squared x plus sine x, and then plus 1 is equal to 0. We'll end up factoring here, but before we factor, let's get rid of this. So how about we just factor out a negative 1, okay? So this will end up being a positive 2 sine squared x minus sine x minus 1 equal to 0. Okay, so let's go ahead and factor. So when we factor, this would end up being 2 sine x plus 1, and we would have sine x minus 1 equal to 0. Okay, let's set this equal to 0. Sine x would end up being negative 1 over 2. Set this equal to 0. Sine x would end up being equal to 1. Okay, these actually fall under our unit circle, so you can simply just look those up. Your answers would end up being pi over 2, 7 pi over 6, and 11 pi over 6. So those are equivalent to what those are when it comes to space angles.